High in a place of honor among the industries that make America great stand the railroads of this country. Performing one of the most magnificent industrial operations in the world, the railroads bring men and machinery together to help build our country's prosperity. The skill of countless engineers and the products of many scientific laboratories are called upon daily to keep our trains rolling. One of the most interesting and important applications of science is found in the modern automatic signal system. This system is based on the use of extremely intricate yet fully dependable instruments which are in round-the-clock operation. Signals have been developed to a high degree of perfection, not only for safety's sake, but also to promote efficient and rapid operation. Yes, they keep the trains rolling to make America's railroads truly the lifeline of the nation. When railroads were new and 15 miles an hour was a dashing speed, there was little difficulty with traffic congestion. In those days, railroads were run by the calendar instead of by timetable. One of the earliest types of signal was the black ball hoisted on a pole. From this crude device came the term highball, that means go ahead to all railroad men today. As the railroads grew, trains became more numerous and speeds increased. This brought about new problems of control. While safety was of paramount importance, there was another factor to be considered. A way must be found to increase the efficiency of this important new means of transportation. A system of written orders was developed, giving train crews positive authority to proceed. Thus, hand-operated signals came to be placed at each station. The trains could not proceed until the orders had been read by the conductor and engineman. About 1872, the automatic block signal was introduced. The electrical age was coming to the railroads. Here was an automatic means to tell the engineman of traffic conditions ahead. The passage of a train caused the signal to operate. The slow and cumbersome system of written orders could now be dropped. In order to make automatic signal operation possible, the track must be divided into sections called blocks, which may be compared to city blocks having traffic light control. However, traffic lights are operated at fixed intervals, while automatic block signals are operated by the passage of trains. Tracks protected by automatic signals normally have an electric current flowing through the rails. Hence, at the joints, rail ends are connected by bond wires to ensure perfect contact. Blocks, on the other hand, are separated by fiber insulation at the joints. Housed in nearby metal cabinets and connected to the circuits are sensitive relays which form the heart of the signal system. These relays are magnetic switches and respond to any change in the normal flow of current. When a train moves into a signal block, an electrical connection is established between the two sides of the track. This change in the flow of electricity operates the relays, which control the movement of the signals. In the event of a broken rail or equipment failure, the signal will move to the stop position by gravity. Early semaphore blades were made to show green or yellow by dropping below the horizontal. A somewhat improved type makes all movements above the horizontal. This takes better advantage of the principle of gravity and requires less power for its operation. As train speeds increased, it became necessary to expand signal protection. A second semaphore blade was added to give a greater variety of indications. Thus, the first indication behind a train is red over red, showing the presence of a train in the block ahead. When the second block has been entered, the indication changes to yellow over red. Entering the third block causes the signal to show yellow over yellow. And finally, as the train goes into the fourth block, the signal clears to green over green. This completes the four-block protection behind each train. For each of the many color combinations, there is a definite rule that must be thoroughly memorized by operating men. They are clearly set forth in the standard book of rules and in employee timetables. These signal rules are ironclad, and there can be no exceptions to their wordings. We generally think of a signal as a device to stop a train. However, it plays an equally important role in keeping trains moving. It may warn of danger ahead, but ordinarily it tells the engineman he may proceed safely. As signal design progressed, the semaphore type began to give way in favor of the searchlight type, a powerful beam which can be seen for great distances, even in broad daylight, and gives greater visibility. By means of a mechanism which moves colored screens in front of a searchlight, the light beams are made to change color. If the operating current fails for any reason, gravity moves the center or red screen into position. If the searchlight itself goes out, the engineman must consider the signal red until he has been instructed to the contrary. There are several ways of mounting signals. Usually the train speed determines the height above the ground. Space considerations may determine whether it is to be placed on a mast or other support. When a number of tracks must be spanned, a signal bridge is erected. A cantilever support may extend over 2 tracks in order to place a signal in the correct position. The dwarf signal has the same mechanism in a low housing for service in yards where space is restricted. Even the lamp on a switch stand is a signal indicating the position of the switch. On high-speed mainline track, the signals are approximately 1 mile apart. However, since the spacing is determined by the stopping distance of trains as well as other local factors, there can be considerable variations. As a train approaches a signal, the engine crew call the indication aloud to each other. This serves as a human check. New York Central trains have an automatic safeguard to make the signal system even more positive. A coil device called an inductor is placed at each signal and connected to the circuit. A companion device called a receiver is mounted on the tender truck of each locomotive. If a signal does not show clear when a train approaches, the engineman must forestall by pushing a lever at his side. If he is incapacitated or for any reason fails to forestall, the device will automatically go into action. The train will make a normal stop and cannot be started again until the brakes are unlocked. This can be done only by operating a device mounted on the rear of the tender. When the action has been completed, the engineman can release the brakes. There are locations on the New York Central where the automatic block signals must give way to a more flexible system of control. At junction points and terminals, for example, it is necessary to use considerable planning and quick thinking to handle traffic. In such locations, we find signal towers, where various types of control boards are operated by tower men. There must be a careful coordination of switches and signals to provide the utmost in safety and efficiency. They are operated by electric power and controlled from a central point. The key man in a tower is the director, who plans all operations. The lever men assist him by actually operating the controls. By teletype, loudspeaker, and telephone, he receives information about approaching trains and where they will be placed. A diagram board with tiny lights shows the position of all trains within his jurisdiction. Although the men in a tower may often see much of the area they control, their work is governed by orders from the director. The language in a tower sounds strange indeed, but it is simple and direct. You might hear a director call 4 to 16. He would mean that a train coming in on track 4 was to be routed to track 16. His levermen would then start moving the necessary controls to line up switches and signals for such a route. Equipment like this is called an interlocking plant. The movements of switches and signals are so interlocked that it is impossible to set a signal to show clear when a switch is in the wrong position. A system of notched bars, magnetic catches, and locks is so arranged that operations must be performed in a definite sequence. The safety features involve both mechanical and electrical checks. This intricate yet rugged mechanism is built to stay on the job 24 hours a day. Without it, railroad operations would be slowed to a snail's pace, and the danger of accidents always would be present. Millions of dollars are invested in signal equipment in order that the railroad may do a better job. Even a momentary shutdown of an important tower would result in a serious tie-up of traffic. Backing up this vital nerve center of the railroad is a vast organization of men always on call. Within immediate reach of phone or whistle signal, a maintainer can go into action instantly in case of trouble. Armed with modern tools and a full stock of spare parts, the men are ready for any emergency. Safeguarding trains must be the first consideration. Freight and passengers cannot move unless the signals operate properly. In all installation and maintenance work, there must be a heavy margin of safety. Accordingly, each operation must be double-checked and standard practices rigidly followed. Here is a simple device which is placed on the operating levers while work is being done on a switch. Even if the towerman should forget special instructions, he is prevented from moving the control. Gasoline motor cars provide convenient transportation for inspection trips and emergency runs. A ride in one of these can be rather chilly in midwinter. Preventive maintenance in the form of constant testing plays a large part in keeping signals functioning smoothly. Every circuit must be checked regularly. Plans and blueprints enable signal engineers to locate every wire and terminal instantly. Equipment behind the scenes is kept spotless. A neat appearance helps to promote efficiency, and cleanliness of electrical units means better operation. Men who are neat in their habits do better work. As the density of traffic increases, new methods must be introduced to carry the load more efficiently. At this point on the water level route is one of the most modern signal plants in the world. A touch of the hand does the work that formerly meant many steps and several vigorous arm motions. Once the route is selected, the operator simply turns a knob at the incoming point and pushes a button at the destination. The machine does the rest. Tiny indicators show the switch movements, and red lights flash when they are locked in proper position. One after another, the electric switch machines operate until the route has been completed. When the last switch has been moved, the signals protecting them flash the final go-ahead to the engine. These trains may proceed safely because they are fully protected. No switch or signal can be moved which might endanger their progress. The heart of this marvelous plant is the room where more than 1,600 relays are located. They are hooked up in amazing array and replace the many notched bars and magnetic catches in the older style towers. Every wire has a number and can be traced to any point in the plant. The maze of circuits requires thousands of wires, which are carried outside and combined into cables. They spread out over the yard and are carried along the line, scores of switches and signals. Electric power ordinarily comes from commercial lines, but standby sources are always on tap. Storage batteries can provide ample current as a reserve source. Again, a regular routine of checking serves to keep the plant in top-notch condition. These flashing lights indicate the absence of grounds in various circuits. When you make your next train journey, pause a moment to think of the marvels that make your trip a safe and pleasant one. Think of the scientific research and the engineering talent that made the great signal systems possible. Think of the millions of dollars that the railroad has spent to enable your train to speed safely across the country. All are a part of the New York Central's modern, progressive plan to give America a better transportation system. In signal language, they say, a clear block ahead.